We're going to do some trigonometry examples just to get you started. You're going to need a calculator with trig functions. This is the one that we use in the class. However, if you have this one will also work. But I'm going to go ahead and show you using the pink calculator, or the TI-30X2S. Okay. In trigonometry, we are working with right triangles, and basically we can figure out two sides if we know one side and one angle other than 90. And so we're going to go ahead and go through some examples. First, I'm going to draw a right triangle, and we're going to talk a little bit about how to label the sides in accordance to the angle that we're working with. And it doesn't matter, you know, what your right triangle looks like, you just want to draw one. Alright, now I'm going to say that this angle here is 42 degrees. And we're basically going to be labeling our sides in reference to this angle here. I'm declaring that we're going to be working with this angle. So the sides are going to be either hypotenuse, adjacent, or opposite. Okay, and that's how I'm going to label it. So now the side that is opposite the angle is going to be over here, so this is going to be opposite. The side adjacent or next to the angle, but it's not this long one. This long one has a special name. It's called the hypotenuse. And the other side next to the angle is called the adjacent. Okay, so we've got three sides: opposite, adjacent, hypotenuse. Now the hypotenuse, if you recall, is always opposite the 90-degree angle, and it's always the longest side. Now what if we were to say we were referencing this angle, and we said this was 48 inches. Okay. Now if we were to label the sides based on this angle, we would have to make some changes. The hypotenuse, of course, would be the same. Okay, this would continue to be hypotenuse. But notice that the opposite is actually over here. Okay, this would be the opposite. And this side would be adjacent to that angle. So that's why it's really important to make sure your sides are labeled according to the angle that you're using, whether it's this one here or the pink one over here. Alright, now we're going to talk about functions, and let me go ahead and write them out, and we'll talk about them. So the first one is going to be sine, cosine, and the third is tangent. Now on the calculator, if you look, let's look at the calculator real quick. SIN is the sine, COS, cosine, TAN, tangent. So if you want to put that in your notes, you know, I'll just put it in parentheses, and that's going to represent the calculator version. Okay. Now a good way to remember, let me backtrack. These functions represent a ratio of two sides. Okay, and so sine is going to be a representation or a ratio of the opposite. So sine is the opposite over the hypotenuse. Cosine is going to be the ratio of adjacent over hypotenuse. And tangent will be the relationship or the ratio of opposite over adjacent. Now another way to write these out is so, sine opposite hypotenuse, ca, cosine adjacent hypotenuse, and toa, tangent opposite adjacent. Okay, so with all of your problems that we're going to do on the assignments, I want you to write Sohcahtoa, whether it's like this or like this, on your paper for each problem. And I'm asking you to do that because through repetition, you're going to remember these functions. We're going to be using them quite a bit the rest of this quarter, and so it's important for you to have them memorized. All right, let's go ahead and set up a problem, and then we'll start using these functions, and also you'll get some practice using the calculator as well. All right, I'm going to draw another triangle. And with these triangles, we're just going to solve for one side. You might have other problems where you'll have to solve for two sides, but just to start off with, let's just solve for one side. And let's say that we have 35 degrees here, and I'm going to give you one side dimension. Let's say we have 42 inches, and we want to solve for letter A, side A, okay? Now the first thing we want to do before we do any math is label our sides in reference to that angle, okay? A is going to be the opposite side, okay? And 42 is going to be the adjacent side. And I know it's adjacent because this side, this really long, or this longer side, is the opposite of the 90, and that's the hypotenuse. So the other adjacent side is going to be what we refer to as adjacent. Okay, so I'm going to write Sohcahtoa. And this is how I think through it. I want to pick a function that has what I have, which is the adjacent, and what I want, which is the opposite. So which function has both an adjacent and an opposite, or an opposite and an adjacent? Well, tangent does, and you can see it here, opposite and adjacent. So this is how we're going to write it out. We're going to first write out the function tan, and I'm going to use these calculator abbreviations when I'm writing it out. So tan, and then we're going to input the angle. So tan 35 equals, and then we're basically just setting it up as this ratio, opposite over adjacent. Now we don't know the opposite, so I'm going to write opposite, or op, and then I'm going to plug in my 42 for the adjacent. Okay. Now, to input this into the calculator, we've got to move things around. We want the opposite to be all by itself, and so what we're going to do is we're going to multiply by 42 to both sides. And by doing this, I'm getting rid of this fraction setup. Okay, so this cancels, that cancels. I can rewrite it as 42 times tan 35 equals opposite. Notice my unknown variable is isolated on one side of the equal sign. Now, once that's the case, I can get my calculator and plug it in. So let's go ahead and do that, and we'll work through it together so that you know how to get it in. So we're going to take that 42 times, and then we're going to hit tan 35. Now notice on your calculator screen there's an open parentheses. You don't have to put a closing parentheses. You can if you want. You would have to, however, put the closing parentheses if you did tan 35 first and then multiplied it to 42. If you didn't, you would get a different answer, and so in that case you would want to do that. So you can if you want, you don't have to if it's inserted like this. So we're going to get 29.4087. I'm going to round to 3 decimal places, so that's going to give us 29.409. Okay, 29.409. All right, and then of course we're going to convert to the nearest 16th, so we're going to subtract the 29 times 16, and it looks like we've got 6.5, so that's going to bump it to 7/16. So A is going to be 29 7/16. Now let's just look at that a little bit and talk about the size of this angle. Now, one thing about the angles of a right triangle, here we've got 90 and we're given the 35. The sum of these interior angles are going to equal 180. So if I subtract 35 from 90 minus 35, I'm going to get 55. So this angle up here would be 55. So if we just look at the angles, the way the size, because this is the smallest angle, this has to be the smallest side. And because this is 55, that's the middle size angle, this is going to be a little bigger than this, but not as big as the hypotenuse. We're not solving for the hypotenuse, but that's just something you want to keep in mind. So you want to ask, is this a reasonable answer? Yes, it's reasonable because it's opposite the smallest angle, and this is smaller than the middle side. Okay, let's move on and do some more examples. All right, let me draw another one here. And I'll say this is 42 degrees, and instead of let's see, well, let's do this. How about we have 24.5 inches, and I want to figure out this side, letter C, side C. Okay, so again, I'm going to write Sohcahtoa. And then it's important to label those sides. This C side looks like the hypotenuse. It's opposite the 90. This is going to be our adjacent side. It's next to the angle, and it's not the hypotenuse. So we want to pick a function that has adjacent and hypotenuse. And if you're thinking cosine, you're correct. So again, we're going to write it as cosine or cos 42 equals, and the way the function is written, it's adjacent over hypotenuse. Adjacent is 24.5, so 24.5 over hypotenuse. Okay, so again, we've got this situation where our unknown variable is attached to another number. And so we want to break up this fraction by multiplying the denominator of this ratio to both sides. So I'm going to multiply the hypotenuse, which seems kind of weird because that's not really a number yet, but it does represent a number. So let me do it to both sides. And this is going to cancel. And I'm going to just go ahead and rewrite that. So hypotenuse times cosine 42 equals 24.5. Now notice that our unknown part is still attached to another quantity, and so we want to do the opposite of multiplication. We want to do division. So we're going to divide by the part we want to get rid of, which is the cosine 42. And again, we're going to do the same thing over here, divide by cosine 42. Okay? That essentially means we can eliminate that cosine 42 on the left. We're left with hypotenuse equals 24.5 divided by cosine 42. And this is what you would plug into your calculator right here. So let's go ahead and try that one. And we've got 24.5 divided by cosine 42, and we're left with 32.968. And we'll go ahead and convert this decimal to the nearest 16th. So subtract 32, and we're going to multiply it by 16, and we get 15.4, so that's 15/16. So 32 and 15/16. Okay? And now this needs to be larger than this side because this is representing the hypotenuse, and it is in fact larger than the adjacent. So I feel pretty confident, or that this is a reasonable answer. Okay, I'm just going to call it that. It's reasonable. All right, let's go ahead and do another one. Let's say we have let's say we have one that's 58 degrees here, and I'm going to say that we'll have, let's say we have, we have 14 and 1/8, and we want to figure out the c side. Okay, and so I'm going to write Sohcahtoa again. Okay, sorry about that. Okay, and let's label our sides in accordance to this angle. This should be the opposite, and this should be the hypotenuse. So what function has opposite and hypotenuse in it? Looks like sine does. Okay, we've got opposite and hypotenuse. So I'm going to rewrite that as sin 58 equals opposite, which is 14, and I'm going to write this as a decimal, so it'd be 0.125 over hypotenuse. And I don't know what the hypotenuse is. Now, this problem here is very similar to the one that we just did. Notice that our unknown is in the denominator here, just like this one here. And in this case, in fact, it was the same variable as the hypotenuse. So we're going to multiply by the hypotenuse to both sides, and that's going to cancel. And if I rewrite it, it's going to look like this: hypotenuse times sine 58 equals 14.125. Now again, this is associated with this function, so we want this by itself. So we'll go ahead and divide by the part we want to get rid of, which is the sine 58, and we have to do that to the same on the other side, so we keep the balance of the equation. That cancels, and we're left with our unknown on one side and everything else on the other. So we're going to input into our calculator 14.125 divided by sine 58, or sin 58, however you want to say it. So let's go ahead and see what we get. Let me see if I can get the light going on here. Okay, now we can see 14.125 divided by sine 58, and we get 16.656, and I'm going to convert this to the nearest 16th. And I get 10.4, so that's going to be 5/8. So 16 and 5/8. And is this, in fact, bigger than this opposite? It is. So this answer is reasonable. Now, so I did 3 problems. I did 2 that had this extra step of solving, you know, of setting it up so we can input it into the calculator. I did an example for each function. The first one was tangent, the second one was cosine, and the third was sine. But understand that for each function you're going to have 2 possible setups. In this first one, notice that it was really just a multiplication problem. You're multiplying whatever that number. If the number is in the denominator, you're just going to take that number and multiply it to your function. Whereas if the unknown is in the denominator, like here and here, then it winds up being a division problem. Okay, here it's dividing, and here you're dividing. Now, the more that you do these, you're going to see the pattern. You're going to see, you know, there's actually a little trick to this. I'm not going to show you the trick because I want you to do these problems over and over again, and then you'll have that light bulb moment and see the trick, and then you'll do the trick because it will be obvious to you. But the key thing with all of these problems is draw the triangle, label the sides in reference to your angle, and then choose the function that has what you have and what you want. And then, of course, set it up so that you can solve for that unknown side. If you have questions, again, ask me in class and we can do more. You'll get lots of homework, lots of practice this quarter.